Thank you, Jeremy. Thank you, Paul. Always a pleasure to be back at WAF. I do remember the one of my first visits to WAF was over a decade back, and I've been to several in between. But what a difference! What a different world it is now. From the thousands of people in the lecture halls and the hundreds of people in the jury rooms to where we are today. And what a great opportunity to be able to speak to the people who make this world habitable, and to be able to share what we've been able to do over a period of time in trying to address that condition. And it'll be great to hear solutions from around the world as well. And I think sort of together we can come up with a methodology by which we can craft a better future, not only for the people who inhabit our buildings, but for the people who make them. On that note, I'll start my presentation. I always do. Sorry, is everything okay? Right. So this is my most favorite slide of all. That's where morphogenesis started in a way. Morphogenesis means the origins, development, the structure of form in nature. And a lot of it goes back to very early thinking from where me and Sonali studied from the School of Planning and Architecture in Delhi. And those are socialist times, to the A in London, where I worked with CMOS and learned a lot about sustainability and passive design, and John Fraser, who to date spends all his time trying to crack nature to find a better model for architecture. But the key to all of this has been the fact that the most beautiful piece of architecture that I think exists is the termite hill. And it seems to do everything that we strive to do in architecture. It's extremely sustainable. It works with local resources. It's extremely unique in the sense that a whole community comes together of workers, of soldiers, and to create this incredible machine, which really has no input energy, and yet it maintains in extremely difficult environmental conditions the perfect conditions for this colony to exist. And what is even more stunning is the fact that the most complicated physics of computational fluid dynamics pertaining to the Venturi effect, the stack effect of hot air rising up, the wind forces, homeostasis, humidity control, are all done by a collective. And it is this collective that makes this incredible machine. And there is no singular architect, there is no singular engineer, it is the community. And it is the community of this living species that creates this most incredible and sustainable piece of architecture which has survived, not for 100, not for a 500, but for an incredibly long period of time. So we took a lot of those learnings over the last several decades of research, and combining that and looking at and having the opportunity of living in a country like India after we came back from the A, was to see architecture built by the people over thousands of years, and to see those similarities with how nature builds. And we sort of brought that down into a design process, which, like Jeremy said, we call Soul, which we copyrighted, not because we want to own it, but simply because we think that design processes should become not only copyrighted by architects, but should become freely available to everyone. So on sustainability, our objective for the last 2.5 decades has been to create an architecture that is net zero in energy, net zero in water, and net zero in waste to landfill. And you must understand that these are the conditions that we work with in India, where resources are incredibly limited and only available to a very limited few in the affluent section, while most of the country, India, 1.4 billion people, do not have access to the simplicity, the simple things of life, water, energy, etc. Optimization is based around the fact that we want to be carbon neutral, and to achieve that by relying on local resources. Louis Kahn said form follows function. In India, we believe that form follows finance. And it is that limited finance that gives rise to understanding how do we move ahead and create optimization in the architecture we produce. Uniqueness has to do with relying on tradition, heritage, culture, and learning from people, learning from communities, people who've built for a very long time and survived and sustained. And livability is about building resilient communities, which is where I'm going to be more focused today. But not the resilient communities who only inhabit the buildings, but the resilient communities who actually build them. And there's a contrast in India between the financial institutions who fund these buildings, the clients who build them, the people who work in them, and the people who build them. And there's a whole hierarchy, a socio-economic disparity in how that ecosystem works. And the question as architects we have always posed ourselves is how do we address that condition where architecture has to be equitable to not only who we build it for, but through the entire ecosystem. Uh, but we were faced with this very unique condition, this COVID, this pandemic. I mean, we've seen a lot over the last 2.5 decades in India of adverse conditions, but this was a completely new and unique, new and unique condition to work with. And where we ended up with was to see one of the largest migrations post-partition in India, which was terrible, that we've ever seen anywhere in the world. And most of these workers, and now to put it in perspective, India has about 139 million migrant workers. That's an extremely large number, and most of these people move from their homes, their rural areas, their communities, to cities, and to do only one of two things: either they work in factories or they make buildings. And half of these actually work and make buildings. In fact, most buildings that are built in cities are built by migrant workers. And if anything else, this pandemic will affect this population a lot more than anyone else. And of course, as you see on the screen, 400 million workers are to be affected by the pandemic and its lockdowns that followed through. These are just some visuals to give you a sense of what actually transpired in those lockdowns. Millions of people walking on foot for days across hundreds of kilometers trying to get back home because all transport had been shut down. The city as an ecosystem had stopped functioning, and in a sense, not about how the other half lives, but how the other half works. It came to the fore, and these images haunted us for a very long time. And there's a reason why this happens in India, and we started looking into that. If you see the map of India on the left, the dark green portions is where the maximum amount of population in India is, and that's in the north. It's because the Himalayas, brought down minerals with the water from the glaciers, and that land was highly arable, and so a lot of agrarian communities grew there over a large period of time. And then if you see the coastal region on the left and the right, where you see the dark greens, are due to the farming communities. But that's not really where we are actually building. Where we are building are in the metros and the cities, and therefore the mass migration, and which is sort of highlighted in the map on the right. And I'm going to try and show you projects in these areas where we are trying to see if when we build there, how do we keep these local communities from not having to migrate, and what can architecture contribute and what can architects contribute in that condition. So I'm going to go back to a project. This was in 2009, and we presented this project at VAF in Barcelona. It was a phenomenal experience. I mean, we'd never seen anything like that before, an event at a global scale. And I think the project, this won the best learning building of the year that year, it caught the imagination of a lot of people. And I think in that sense, it was a really fundamental point in time for us, because it reinforced this whole sort of ideology that sat, not only that sat behind Seoul, but it also brought to this part of the country global recognition for a project which worked with traditional solutions and local craftsmen to address a very, very simple problem. And that simple problem was a lot of our institutions and a lot of the architecture and a lot of the buildings in India are built in a very, very specific price point, and that price point runs at about $200 per square meter to the higher end, which would be at about double of that, $400 per square meter. This was at 200, and at that time we weren't really trying to save the planet or save the communities. We were just trying to get this building built. This is we started this about a decade and a half back, and it completed in 2009. And the only solutions we were finding at that time, which defined our practice from that point onwards, was to rely on traditional low-cost climate tempering techniques, keep the air conditioning out, keep the heat out. How can we naturally cool these buildings? We looked at a lot of traditional architecture, and we looked at the use of jalis and the use of baulis, and how could we begin to contemporize and use this in modern day architecture, and with the sole intention of not only removing the air conditioning from the building, but because infrastructure is unreliant, that also means you remove all the power backup, the diesel generating sets. There's this whole cascading effect to making these buildings passively self-sufficient, and being one of our first net zero buildings. So yes, of course, we plagiarized from the past. We had the Bauli, we recirculated the water, we created a cooled sink 3 meters below the ground and used that to cool the building from within. Just another shot of the contemporary plagiarization of traditional stepwells. They're fantastic, these stepwells. I mean, with when you go to these stepwells at 46 degrees Celsius outside, they are at roughly about anywhere between 25 to 30 degrees Celsius at the bottom of the stepwell, and that's simply because of the earth banking and the water and the water evaporation. We looked at how do we build these screens, these jalis. Of course, anything from the manufactured, mass-produced contract world was way too expensive. We worked with the local jali makers who on site made these cementatious jalis, which was absolutely great because it gave them employment at the time, which wasn't really our prime concern, honestly, at that time. But we were able to put up the screen, which provides a lot of environmental control for a fraction of the price what a contract manufactured product would have done. We were trying to work out how do we work with insulation in a desert climate, because Jaipur, where this project is, goes up to 47, 48, 49 degrees Celsius in the summer. And earthenware pots, there's a whole community that builds earthenware pots that naturally keeps food and water cool, not having refrigerators and not having power supply. And we use that as insulation. Air being a great insulator, we inverted them, put screed on top, and effectively, a combination of these communities, and these were in fact pictures from the time where this whole potter community was making pots for insulation for a building which they had never done before. And that's where we ended up with this building. To date, with external temperatures of 47, without air conditioning, it achieves 29 degrees Celsius inside. That's an 18-degree delta. It's in terms of its energy performance index, it's at 25 kilowatt hours per square meter per year to date, which is just 25% of what a green rated building would be at today. And looking back, we gave 120 potters and jali makers employment on the site for a year, supporting that community. And like I said, we weren't really trying to do that at that time, but in these current conditions, we thought, wait, that was phenomenal. And how could we begin to work upon that? I'm going to now jump across to a much larger size project that is currently going on, or rather nearing completion. And this is in a city called Kolkata, which is sort of diametrically opposite on the eastern coast of India. And Kolkata is again, comes from the Bengal region, where there is a tremendous history of tradition, art, knowledge, and culture. And that tradition goes back an extremely long period of time. Just to sort of put into context where Kolkata really is, like I said, it's a warm, humid climate, and there's a very strong sense of identity. And for those people who are not very familiar with India, India is a bit like the European Union. It's the Indian Union. It's we are not all Indians. We are first Bengali, or we are first Tamil, or we are first we're from the states first and from the country second. and that's because our cultures from in each of these states is so strong because of the climate, the food, history, the craft, the arts, that our identities emerge from there first. And like a government official once told me that India is a nebulous entity, or Indianness is a nebulous entity. So, of course, we did our usual design for this. It's about 300,000 square meter campus. It consists of offices, some residential apartments, a hotel, a convention center. So the entire design was based around, of course, the wind flows so that the warm, humid environment could be alleviated, and wind is a great alleviator of humidity. But also, all the buildings were designed to be 18 degrees to pure north, because Calcutta is at an 18-degree latitude, and that helps cut down solar radiation tremendously. But more importantly, we were beginning to think about this was about 3 or 4 years back, that how do we begin to bring this community of great artisans? If any one of you has been to Calcutta, you would have seen the incredible work that goes on for sculptures, for crafts. And the sad part about that was the fact that most of this community basically is active for only a short period once a year, and that's during the Durga Puja. And beyond that, this is a dying community, and people from here have been migrating to other parts of the country to work on construction sites, etc. And we began to think about how do we incorporate some of these ideas. So we worked with one of the artist communities there, about 40 impoverished artists. The sketches that you see on the bottom left of that image was what they came up with. We, of course, worked upon those internally, and we came up with abstractions of those on the right. Our objective was really to see, can we bring arts and crafts to architecture in a way that not only celebrates the arts and the crafts, but brings about the fact that though our buildings will be tending more and more to being manufactured, but we do also think that there is a certain beauty to the future being handmade, and in supporting these dying communities and preventing them from migrating. We also worked with a part of Bengal which is very, very proud of the script. According to Wikipedia, it's the second most used written script in the world. Part of it is also Sanskrit, and we started getting this community of craftsmen to hand cut these into stone. So that's an image sort of showing the western facades, which we wanted completely blocked, to carry these handcrafted sculptures or murals, if you may. Just some pictures of this combination of handmade and hand-cut technology of carving these pieces of stone, combined with dry fixing on the western facades. And it's kept these 80 craftsmen on our site now for several years as the project completes. And eventually, they would have contributed to this 300,000 square meter mixed-use development. It's about this urban art facade, if I may, is about 500 meters in length, about 100 meters high, and with a total artwork in stone of about 10,000 square meters, all handmade by this community. And this community now for 3 years has been supported entirely by this project. Now, it's great because it serves many purposes. It was a west wall. The stone provides insulation. It brings identity to the project from the Bengal region, and it supports the local community. And like I said earlier, form follows finance. It's effectively a very, very economical way of bringing craft into architecture. I'll go across to my third example, and this is an interesting one, where this is the Surat Diamond Post. It's located near Mumbai, about 500 kilometers from Mumbai. It's again a coastal climate, but it has an issue. The issue is that, of course, as most of you probably know, that most of the world's diamonds are polished and cut in India, and all that work happens by largely by a singular community. They come from a region called Saurashtra in Gujarat, And there were these 70,000 diamond workers roughly travel 100 to 500 kilometers every day to Mumbai, where these diamond cutting industries are. Now, looking at the sort of typical pattern of a person who works in this industry, a diamond cutter, starts his life at 4:30 in the morning in 500 kilometers away in Surat, takes a local train, comes to Mumbai, takes a bus, works through the day, and then goes back at night. By the time they get home, it's 10:30, 11 at night, and they start the day all over again. Of course, the travel, the commute, the transportation is in extremely crowded environments, as you can see from the pictures on the right. And this community got together. It wasn't our doing. They got together, and 4,000 of these diamond merchants, along with these 70,000 workers, decided to relocate the entire industry out of Mumbai back to where they actually live, which is in Surat. And the reason for that also was to provide a better quality of life, to cut the commute, the migration, and move this whole industry into a single building. Just an example of how the current working conditions in Mumbai are. Mumbai is an incredibly dense city, very expensive. It also has the displeasure of having the largest slum in Asia, Dharavi, and that's where a lot of these people would end up living. So the act of their relocation back from Mumbai to Surat was also dependent on a very unique criteria. They were said, if you're going to come back, we want to be able to work as one community. And what does that really mean? And this is resilience. They said that we may work in 4,000 different factories, but we want all of us to be in the same building. And not only that, we want to be able to operate as a single organism. What that really means is you compete and cooperate. So if a particular diamond factory gets a really large order, they can all 4,000 work as one single factory, or they can compete for different clients. And that required us taking the number of people and the activity required to make a building that is currently at about 650,000 square meters, one building, to serve the needs of 70,000, 65,000 diamond workers, but to work as a single community. From what we understand, and I would like to be corrected if you're wrong, is that this is now the single largest office building in the world at 650,000 square meters as a one single building. And of course, it posed several problems. The first was, how do you get 70,000 people into a building, in and out, into one building? And we mapped some metrics because, of course, everything was rotating around the notion that the lifestyle, the living conditions, the working conditions of these 65,000 workers has to be exemplary for them to for them to be able to use this building in a way that would make them comfortable. And we set ourselves some tough metrics. We said that from the perimeter of this 35-acre site, every worker should be able to get to his diamond cutting machine in under 5 minutes. And a lot of the setup of the master plan, which you see in the top 6 images, was based around that. So there's a central spine, which is the community space. And then there's these wings, which allow for 100% daylighting through those courtyards for each of those 4,000 offices, and allows them to operate as a single organism. And at the same time, what you see in the top 3 images was how the vertical transportation, the horizontal transportation of people was done. So there are about 120 lifts distributed in this building into multiple cores, interconnected. So much like the central nervous system of a living organism. I mean, excuse the fish. Sonali insisted I should have it there, but the idea really was that how do you create a single organism that can operate as 4,000 independent nodes, but as a collective neural network. Oh, okay. I've lost my connection to OctoQ. So yeah, thank you. So that's sort of the layout of the plan. There are about 14 stories of this. Each floor is about 40,000 square meters. but it's fragmented to allow, like I said, natural daylight and natural ventilation. The central spine that you see running through the middle is designed to capture the north-south winds and, through a Venturi effect, drive them through the central spine, thereby cooling it naturally. Next. So these are, and this is sort of a section, cutaway section from the spine, where we have these sort of vertical lungs, which, when the wind is not blowing, allows for the stack effect, much like in the termite hill, of this natural air to go through. And the reason was that there's 60,000 square meters of this community spine that runs through the entire building was to be kept naturally ventilated and comfortable through the year, given the fact that it's a highly humid and an extremely hot climate in the summers. So we have these sort of fluidly shaped vertical lungs, if you may, that allow that to happen naturally. Next slide. The courtyards are all designed to allow for informal trading with people, with external traders who are not working within the building, and again in a highly secure environment. Also, to use these external courtyards uh, in a security zone for eating, for trading, etc. Next slide. Yeah, and of course, the only way in that aggressive climate we could have kept these community spines naturally comfortable was to do structural cooling, which is about 60,000 square meters of structural cooling. It's about one of the, I think it is the largest gradient cooling installation in the world. The point about all of this is that this has been done by a combination of 4,000 traders and 65,000 workers. It's their initiative to shift an entire industry back to where they live, to improve the life of people who work in this building. I mean, it's an incredible feat of effort to be able to go ahead and do this. Next. And of course, yeah, and that's sort of, the building is approaching completion. Right now, it's if not for COVID, we would have finished, but it's aimed to finish by next year. Next. And yes, it's from what you see in those pictures, those are pre-COVID, and just as the site opened during when the lockdowns ended. In 2 years, they've been able to do this, and another year from now, a 650,000 square meter building built by the 65,000 workers and the 4,000 traders would have put together on their own initiative a model where industry relocates to where the people live. And it's just been fabulous to see this effort of cooperation where there is no single client, and it's all internally funded by them. There is no external funding, and it's just a cooperative who's just come together and done this to protect the future of their profession and their trade. Next. So one of those, this will be one of my final projects before I go on to what we're trying to do next. This is a project in the hills. If you remember the India map that I showed you, the north, which is all the Himalayas, are extremely barren in the sense of infrastructure. So barely any electricity, water, roads. The basic infrastructure is missing, which means that most of these people, there are no industries in the hills, and most of these people again had to migrate. So when we were approached by this client is Forest Essentials. They're a luxury Ayurveda brand. They make Ayurveda products for well-being, skincare, etc. And they were looking to make a factory. And we went and saw the location of this site. Next. And so where you see Rishikesh written in orange, it's located right up in the hills. It's in the lower to mid ranges of the Himalayas. And of course, our intention, and we started this project last year. In fact, it finished in the middle of the COVID environment. And our objective really here was to see that could we build a factory at the location where the people who grow the Ayurvedic plants, the local communities, the farmers, can work in a walk to work environment. The challenges: no electricity, no water, no road, and of course, no skilled construction labor or contractors to go and work in that environment. Next. So this is the the product that is made, and it's exported to over 100 locations across the world. But it's made in this sort of very remote, or the people who make this product live in this very remote village, and who were walking kilometers across aggressive slopes to try to get to the current workplace. And the client wanted a solution for that. Next. So this is a view of the site. If you see that little road sort of spiraling up and you look extreme right on that slide, that's the site. So there's really nothing over there. Next. And if you look at the local communities, they and their own local hutments, they use this sort of stone masonry. They use a lot of the local materials in how they live, how they survive, and how they farm. Next. So we mapped out a 1 kilometer radius from this site, sort of more or less in the center of these 800 people who would be working in creating these Ayurvedic products, about 150 hutments in total. And that's how we sort of pinpointed the location of that site. Next. And we designed a building, or rather, let me rephrase that. We worked with them on designing a building that they could build using whatever were the local traditional techniques. Of course, we overlaid that with our sustainability and optimization viewpoint to make it an off-grid building, an off-grid in terms of energy, so it had to be self-sufficient, naturally cooled. It has its own little solar plant on the roof. It had to save its own water to be reused. And we had to carve a little pathway from the road about 1 kilometer away to provide access. So essentially, anything that this building today uses, energy, water, anything that it produces in terms of waste, are all 100% recycled. Much like the amazing termite communities that make that amazing termite hill. It's fully closed looped, and the two graphs that you see on top are how, through passive design, we've been able to achieve the conditions for the manufacturing part of the Ayurvedic products, because they all had different requirements. There was some soap, there was skincare, there were various other kinds of products. Next. Well, we did start a bit late, but be that as it may. So here's a slide of the project that has been crafted by the community. They built it themselves. We had an on-site creche. All the construction details, etc., were designed in a way that they could build it. And next. And yes, that's the sort of finished local building built by the community itself for the community. And like I said, it is now energy positive. We are trying to get some of that back to the local hutments. Next. And that's the building today in use. It's the building started production in the COVID times. Next. Next. And post that, it says now the community themselves have decided to use it as a school. So a phenomenal client making a luxury product for the rest of the world, made by local farmers in a remote hill, a building built by them, by their own construction techniques, and then now a factory which is also a community building. Next. Next. So what this inspired us to do was the only real civil infrastructure we saw there was a post office. And the path that we want to embark on now is to look at this whole sort of these post offices, which are now fully redundant in India given the digital technologies, based around the fact that this is one of the largest physical infrastructure of post offices in the world. Next. So India has about 150,000 post offices spread about. The beauty of these post offices is that they're located in the remotest areas as well, and they have last mile connectivity with the postman on a cycle who can access the last 1 billionth person in this country. Next. Well, I can't right now because you started 10 minutes late. It was time for that. Do you want me to wrap, or can I finish in the next 5? Okay. So these are just some pictures of these remote post offices that you see. They have a lot of identity, but they're in dilapidated conditions. Next. And our objective is to do a simple insertion like we did with the Forest Essential Load Sea project, solar panels, water collection, and convert part of the interior spaces to production units and facilitate with information technology on climate data, on other forms of technology that are being used elsewhere in the world where local manufacturing and local production can take place. Next. Next, that's fine. And yeah, and so this is an advocacy project. It's a professional citizenship project that we've taken up. If you just go to the next slide. We've done something very similar to this. It took us 8 years, and we went through 28 government bodies, and we got a policy change recently in the National Green Tribunal, which is the Supreme Court of the Environmental Ministry, where all these nullas, the leftover drains in cities, are to be converted into clean water drains with issues resolved for sewage, issues resolved for water, issues resolved for public health and mobility, slow mode mobility for walking and cycling. And this exercise next, like I said, took us 8 years. It took us, as part of our advocacy, it took us through understanding complex governance. And like I said, in India, it's a three-dimensional network of over 28 different ministries and offices, and we lobbied all of them. Next. We lobbied the media, and eventually, next, eventually we ended up with getting that policy change. So we hope to do that as well. So yeah, so I will conclude on that. Just a little bit of play on Louis Kahn's word, less is more. I just think that we have a great opportunity. The pandemic has brought us a great opportunity. And like Jeremy was quoting me and saying, it's time to do a lot more with a lot less. Thank you.